Hey everyone, so in today's video, I'll be showing you guys how to calculate the average atomic mass using isotopes and their percent abundance. Okay, so first off, we need to understand that most elements exist as a mix of isotopes. So this means that atoms of the same element will have different numbers of neutrons, And so since each isotope has a different mass, the average atomic mass is a weighted average based on how common each isotope is. So it's important we understand that to calculate the average atomic mass, I have it written down here, it's the mass times the abundance of each isotope. And so sometimes we'll have 2, sometimes we'll have 3, it depends. So that's why there's 3 dots at the end. But it's the mass times the abundance. And we'll always be given the percent abundance, but we have to make sure to convert it to a decimal. So 75% will be 0.75. So now let's do the first problem here together. So B10 has a mass of 10.01 AMU, and it has an abundance of 19.8%. And then B11 has a mass of 11.01 AMU. AMU is atomic mass units, and it has an abundance of 80.2%. So if we're gonna write this out using the formula I have written over here, it will be the average atomic mass is going to be equal to 10.01. Oh, sorry, let me erase that. 10.01 times 0.198 plus 11.01 11.01 times 11.01 times 0.802. 0.802. And so the two values are going to be, this is going to be equal to 1.98198 plus 8.83502. 8.83502. And then when we add those two together, we're going to get 10.82 atomic mass units. So that's the average. 10.82. Now, let's try the second problem. Let's try another problem. So chlorine 35 has a mass of 34.97 atomic mass units and has an abundance of 75.8%. Chlorine 37 has a mass of 36.97 atomic mass units and has an abundance of 24.2%. So for this example here, if we put it into our formula, we're going to get 34.97 as the mass times 0.758 plus 36.97 times 0.242. And so when we get the values for each independently, it'll be 26.52 plus 8.95. And then the total will be 35.47 atomic mass units. Now we're going to do one more example, and feel free to pause the video and try this on your own. But when you come back, you'll see that the main difference here is that now instead of having 2 isotopes, we have 3, which we're doing the same thing, we just have another thing to add. So I'm not going to read it out, I'm going to trust that you did that by yourself, but when we put it into the formula, the average atomic mass is going to be 19.99 times 0.905, this plus 20.99 times 0.003. We have to convert that percent to a decimal. This plus 21.99 times 0.092. I apologize for that last bracket, but when we multiply these out, we're going to get 18.09 plus 0.063 plus 2.023. 2.023. And then when we add them up, we'll get a final value of 20.18 atomic mass units. So quickly, let's recap. The first step is to convert the percent to a decimal. Then we multiply each isotope's mass by its abundance. Then the third step is we add the values together. And finally, we round our final answer to the appropriate number of significant digits. And normally your teacher will give you this value, so you won't really have to worry about that. So I hope this video helped. Thank you.